Hello. Good evening, my friends, my viewer friends rather. This evening we are going to discuss the intake facilities for public water supply system. Now, in my just previous video, in fact, while the discussion was made, but because of some mistakes in the system, the camera settings or so, the video camera, so that was in fact wrongly set in slow motion also, so that is why it was the discussion and also the voice was not heard, so that is why I have to repeat that one. But that video actually, we were discussing that for the design of suction well or this intake well also, right? So there actually, let me tell you that when we are going to, design the suction or intake well also. So what is an intake well? That means this intake well actually, suppose this is a, one port, that is the intake port also that I have shown here, right? Intake, gate, okay? So we will come to that, the intake, this gates also, and then thereafter the intake screen and strainers or racks also, we will discuss that. Now here the overall system, let me sort of explain that when an intake is there, suppose this is an intake like this, right? So the water, this is actually, this is the water level in a river or reservoir or so. This is the water level. Say this is the highest flood level or so. So the other day I was discussing that when we design the intake, this facilities also, remember one thing, that intake facilities or intake works, or in particular intake well also, that is quite heavy structure, okay? So that is why heavy outlay or expenditure is required for constructing this intake, okay? So that is why when you will design that intake, this facilities also, remember that we have to be very careful about the selection of the intake also, right? Intake, the point or intake, facilities. So this actually, you see that this is suppose a river, this one system, okay? This is a river system. This is a river. This is a sort of, cross-sectional or, the front profile or side view of that, right? So this actually, it is not really cross-section also, side view you can say. That means the river is this way, okay? This is the river suppose. So when an intake structure we build here, right? So as you understand, suppose this is the highest flood level or highest water level, okay? And highest flood level means here, that is from the, or based on, past, many years, statistics or so, that what was the, the historically, what was the highest, the sort of, flood level or so. For example, in India, till date, we consider that 1978 flood is actually happens to be rather the datum for the highest flood level, because that reached actually highest level more or less in throughout India also, because of the monsoon, heavy monsoon and late monsoon also, and prolonged monsoon rather. Now this is considered as the highest flood level also, and this is the highest water level in the river, right? So that actually is more or less same. That is why I have sort of used that the oblique also. And while this actually, you see that here, suppose this is suppose the lowest water level, and this is the suppose the normal water level. Now when you will design this one, you have to consider the lowest level as well as highest flood level or water level in the river also, right? Because you see that the lowest water level we should consider, because when the water level recedes in the during summer time, mostly the very leanest period of the year. So in the design period, say according to that AWWA, that is American Water Works Association manual, that actually is taken, or rather you can say in Davies book also. So I will mention the books that means separately here. So what you could follow, because you see that our CPHEEO manual, right, that is published by Ministry of Urban Development, Government of India, which is considered to be a sort of a very important document, right, for planning, designing, operation, maintenance of water supply and treatment also. Similarly, for wastewater sewerage system also that is there, solid waste also there is a manual. So for this actually CPHEEO manual on water supply and treatment, that we will follow, right? CPHEEO manual I will show you later, okay? If you, I have shown earlier, but still just if you okay, I am going, because I don't know where I have kept, so it would be, time will be wasted. I will show this, okay, later in my next class. I will show this one. Also we follow the American Water Works Association. I am just bringing that one because this is just before me. So this actually, if you see that American Water Works Association, so that is the latest version, I suppose the 4th edition also. So this is the water treatment, this plant design, American Society of Civil Engineers, ASC, and also jointly with American Water Works Association also. So this is the year, I am just mentioning the year, that is actually 1990, right? So this is the American Water Works Association. So that actually we many a time we follow this, because what the reason is that that in our CPHEEO manual, where the other aspects of intake that is there, but the design guidelines also, these are not very elaborately and completely discussed also. That is, rather I should say, this is a sort of shortcomings of the CPHEEO manual only in respect of intake design also, because the other things are fantastic, very practical, and it is quotable also in Indian Indian, design projects also, you can say. For Indian projects actually, it has to be, the designers must, follow the CPHEEO manual, must conform to the guidelines of the CPHEEO manual. And also, IS codes, but on intake, I have not yet happened to see any IS code on intake also structure, right? If I happen to have that, I will definitely share with you. So that is why actually the importance of American Water Works Association, that AWWA manual, so that actually this, and time to time actually I will refer to that and I will share with you their design guidelines also. And issues, that is I discussed this in details in our this course on Environmental Engineering 1. So those who have registered for this course, they must have seen that one. Those who have not, then for them actually, I will say that this actually, the intake design also, there actually we have given our contact details also, okay, contact details also we have given, also our email given. But again, as the board is engaged now, so that is why I'm sorry that I am not able to give right now, but I will share definitely this one. This actually, or otherwise, what I can do, I can sort of share, and make it accessible to all. That is our first video in the last course or so. That is the overview, so that everything will be clear to you, and the contact details also. Now, for intake, this one, this is also will follow for water treatment, which will come later. So this is as you see, the water treatment principle and design, that is actually Montgomery. So that is also a very good book, and I have seen that, 2-3 books, reference books, of course. So these are very, very good. That elaborate in much details also, the intake facilities and other these chapters also. One is the Qasim's book, S.R. Qasim, right? So the water works, so that is a title, I may not be correct also, but this is the water works, in which intake also is included also. So this actually we will follow that Qasim's book, then Davis, that is also very good book. I will give the full reference later, right? Davis, or one-to-one this interaction when we will have, that time I will share the names of the books which you can follow for particularly this chapter. So chapter wise actually I will let you know that which books will be better and well suited to all of you. For all of you, this will be there. So this actually, this intake, and for intake actually the Babbitt and Donald, that book also, old book, but that is a new version I have not come across. If you happen to see, you can just let me know that, right? So this is one is that CPHEEO Manual on water supply and treatment also. That is Ministry of Urban Development, Govt of India, and as it is freely downloadable, so this you can see, you can download this one, right? According to your requirements also, the chapters which you will need, you can download this one. and I will follow mostly this one, because you see that this is accessible to all. So that is why, to make it uniform, right, I will mostly follow that one. Where it is not, the CPHEEO manual is silent, or is not sufficient, it is inadequate information also, or it is not at all there. So in that case I will names the other references also. So this, and also it is legally quotable in India, right? Whatever projects relating to this water, wastewater, solid waste also you do, including designs, so that must conform to the CPHEEO guidelines also. Remember this one. But for definitely for projects of assignments in other countries also, their respective codes you will have to follow as a professional designer also. And also that American Water Works Association, AWWA, for the water part, right? For wastewater, AAC manual is there, right? Then UK code is there, they are separate codes. Then European Union, EU codes, that also is there. Asian codes nowadays, that also is there. And other country-wise codes for whichever country you are assigned for the projects or so concerned. So that actually you can follow. So this actually is the background. And then second reference also, that is the American Water Works Association. Okay, that is the manual. Then you can have, this is the major or the main references I am now here giving you. That is that then Qasim's book, Water Works. This, that particular, the title of the books, I don't remember exactly, but here the planning, design, operation, and maintenance, all are there, right? So Waterworks by S.R. Qasim. Fourth is, that is also I think environmental engineering also, that also title I am not very sure about, right? By this may not be, you can see that one, the Davis. The full name also I don't remember, I will share with you later. And other books, like you see that here, this, the Govt book, Water Supply Engineering, where the intake you will get. BD and BD, that also this one. Punmia's book, all Indian, more or less, Indian textbooks also, which are, referred for undergraduate, this classes in particularly in this area also. So you can follow, right? Rather the intake, this chapter on intake, actually these are very nicely covered by the textbooks also, as I have named. Now coming back to this one, so this I am erasing this so that I can create space, I can have more space also. Now our contact, details, that is that WhatsApp, right? My assistant Sohini, her this mobile plus WhatsApp also. So that would be 6289657911, and another, that is the office, this one, dealing with this, online tutorials. So these two phones, mobiles you can use, and the email I have to check that one, right? Email, that is Professor G's environmental ENV tutorials at gmail.com, right? So I will confirm this in my next class, because if one letter is missing also, then it would be wrong also. So that is why I will discuss this one. Now quickly I am coming back, right? Later. Yes, sorry. So email, you may note that Professor G dot ENV tutorials at gmail.com. Okay, so this you will get in our uploaded version. When we will upload, details will come there, right? But here I am giving, so that if anyone is interested to know further about this, so that the person could contact with us. Now with this, actually the introductory, this one parts, the introduction is already that is over with this. Now what I was trying to say, that coming back to our discussion, the lowest water level, you understand that if you suppose your well structure is away from that, so that it is not reaching the water, this one here is not reaching that, this one not cutting this the intake, this well also, that is the suction well also, then you will not get water during summer time. So suppose in a particular year to come, suppose, because the design year is quite long, and as it is heavy structure, you cannot sort of change or modify the construction or design also. So once you have constructed that, you have to sort of maintain, because it is quite heavy expenses, very heavy expenses. It is a sort of very heavy civil engineering structures also. So that is why you have to be very careful while planning and designing, right? So this one will be the historically the lowest water level inside that, so that it could get or receive water or draw water from that. Similarly, you see that on the other hand, if your intake, this one, you see that is lower than that, the highest flood level, historically the highest flood level, as I have told already, that this is 19 considered to be datum, that one reference this year is 1978 or so. So that actually if your intake is dwarf than that means the below this one, then if one incident, such incidence is repeated in your next 60 years or so, because the design life is 60 years, right? So in that case, actually what would happen, this entire structure will be inundated, right? So you understand that, being a civil engineer, that neither it should be below that highest flood level, the top level, it should not be below that one, that means it will be submerged also during that highest flood, the occurrence of that in next 60 years or so. On the other hand, the lowest water level, as I have explained. So it has to be carefully, located also. So, and the other selection criteria already are there. So the theory and principles, right, and different types of intakes also, and their description, their drawings also, you will get a book like this, the Govt book and different other books also, PV and Row. So in these books actually you will get that the background, theory and principles of that. Okay, because here this particular course is on design also, or numerical problems, solution to that, right? So that is why we will not stress on theory or principle also. We will presume that you have got the basic knowledge about this. If you do not have, refer back to your books, CPHEEO Manual, because in the CPHEEO Manual different types of intakes are discussed also. Okay, so that you can follow. I will rather recommend CPHEEO Manual. If something is something more you want, then you can follow the other books as named. Okay, so this actually will be your this approach. That first thing is that how do you find out the capacity of the intake well or suction well, right? So first thing is that this, you see that here it may be right on the river, this one, okay, river bank. So that actually a particular type of intake, the tower intake, or for the river also, tower intake also. It may so happen that means suppose I'm drawing here, suppose away from that, this is the intake here, and here this is, suppose from here it is drawn through a pipe, intake well or intake the conduit also, right? So in that case actually it is coming to that by gravity also, or this actually when it is pumped also, then in that case actually the pump, I am showing just a line diagram I am giving. So this is, suppose the pump is placed here, right? So this pump actually is so this would be normal water level, it would be here also. So when you are pumping, so that from the river also it is drawn towards the intake well, and inside the well this is open, so it is entering into that. And in this case actually what we do actually, suppose the platform is there here, right? A big platform also, it's quite wide, this cross section also, that the horizontal section is quite wide. So there actually the pump arrangements that is made, and that actually here from this actually this will be your pumping, this one. So this is a low lift pump, so that is used. I will discuss in more details later. So through this very simple and very draft sketch, or very illustrative sketch, line diagram also, what I am trying to explain, that the intake may be right on the bank, in which case actually the water comes and enter into this intake well directly, or it may be little away from there, from the river, and it is connected with the river, the intake this works or intake well is connected to the river by a intake conduit also. This is intake conduit also, right? And the pumping arrangements, the pumping station may be in the well itself, or it may be little away, right? Because that depends on the locational advantage also. If in some cases suppose it is so accessibility problems also, then in that case actually the pumping station is is placed or located little away from that, at a place where it is easily maintainable. The pump can be maintained and operated easily, so that way it is placed. or if it is right access is possible also, then in that case right on the intake this pumps, etc., the ancillary structures also, these are located here. So when you will first step is that to find out the capacity of the intake well also, suction well, because that is important, because it has to be held there, kept there, in the well for the supply also. Supply may be continuous, may be intermittent also, depending on the requirements also. Now this actually days, this one or 2 days storage should be there. So sufficient storage capacity should be there. And what we do actually for this actually, which I have discussed in my earlier videos in details also. So we will get that they are all written. Only thing is that as the voice was not heard and it was slow motion also, so that is why actually I am repeating this one. I am not writing because of the shortage of in the board on the board space also, there is a shortage. So first thing is that note down this one, that the design life is 60 years, okay, and this is the design flow, say this one. So if for the volume required for this one or capacity, so that is the Q design. How do you get the Q design? That is the forecast population at the end of say 60 years or so. What is going to be the population by population projection method, that after 60 years what is going to be the population, right, at the end of the design life or so. So that will be your the capacity. So daily capacity also, that will be your this one, because the town will grow, the population will be increasing also. So by a suitable method for this population projection, you can forecast the demand. And demand in the sense I have discussed earlier also in the CPHEEO manual, you will get that for a city or this one, the demand is that I think you know this one, the water demand for a big city, it may be as high as 150 to 250 or so. In Western countries or developed countries, cities actually, it may go as high as 300 even. That is the liter per capita per day. Liter per capita per day. That means per person this much liter, right? So you know that what will be the population at the end of the design period. If you multiply this, then you can get the what is the capacity, that is liters per day or meter cube per day, whatever way you want. So you can convert the units accordingly, and this actually we can calculate this one, water demand. Now this is for the city also. For semi-urban also, in CPHEEO manual you will get all this one, 70 liters per capita per day, where actually the piped network is there. Whereas in the rural this one, where the water is supplied through stand post also, right? For suppose 100 or 150 people, one stand post is provided. People come there and take their water also, and then keep the water at home also. So that actually 40 liters per capita per day. Okay, so these are this one. Accordingly you will decide the intake, but for rural area normally this type of water, this treatment facilities are not there, mostly groundwater also, or the water which will be cleaner or so that but sometimes it may have to be drawn from a river also. In that case the intake may be smaller also in size, so that also is there. If provided that the pumping facilities also, that could be could be installed and operated also, right? So let us sort of follow the design guidelines and procedures considering that the water to be supplied to a city also, population in a city also. Okay, so that actually is how in fact you can consider or you can calculate the volume. And then detention time. That means how long you want to store this one here. Detention, how long you want to detain that water here also. So Q design, that is in say meter cube per day. This is that time, that is in say a day or minute. Normally in this connection, let me tell you that this actually your this detention time here, recommended detention time, in my previous video that all the details actually were were mentioned, right, were mentioned, and I could share that one so that you can get the enter this one, but I have to discuss here also. So this is the, it should not be less than 20 minutes also. That means for 20 minutes it must be stored also, and for a continuous supply system, you know that this is that volume for any storage, this one, when the flow is continuously coming in and going out, then your volume of this storage, this is just box, means entire this one here, it is represented by a box also. So this is the Q design, suppose Q design. So Q design into time, how long you want to detain this one on continuous, that actually the time is V by Q also. That means if you provide a volume V, right, meter cube also, and Q design is continuously, water is moving, so that actually Q, V by Q will automatically decide or determine the detention time. But in this case, as it is recommended that detention time should not be less than 20 minutes, so maximum detention time say 20 minutes you will consider. So this actually gives you the volume is equal to Q into T. Let me write, not otherwise X. The multiplication may be understood as X also. So to avoid that confusion also, V is equal to Q design. I have told that how to find out that Q design, then this times the detention time will decide the volume, and then the intake tower depth, that is to be decided based on the water level, but minimum recommended value, that is the depth of the this one, that is 3 meter minimum. That means you have to get a water column of 3 meters or so inside the intake or suction well also. Accordingly, you have to place your intake well with respect to the river bank also, right? And the section that actually, and once you know that the depth, if you divide that volume by the depth, you will get the surface area, that means this area. And then mostly square also, depending on the land layout or operational layout also. So mostly say square. So in that case you can get that what would be the side dimensions also, right, from the given surface area also. Surface area is the surface area or the cross-sectional area, surface area of the intake. So that would be volume divided by the depth of water inside the intake well. And this is the liquid volume, remember, wet volume also, not the overall volume, because the water at the highest level, so that may be there, and the rest is that remaining is kept as freeboard also. In water supply system or wastewater also, the significance of the freeboard, I think that you know. If you don't know, then you can read it. the freeboard. Why it is kept? Because there is a cushion, it is kept, and also I mean it is well above the water also, so that water splashing or I mean suppose by chance the water level rises also, it should not I mean maybe touch this ceiling in this case, because this is covered here. It is not open like water treatment plant, like filtration unit or sedimentation unit, where it is open. Unlike that, here it is closed. That means it is this way. So you will get the surface area, then find out this one. So first step is to find out this one, right? And here I am just sort of reading it out, that the bottom of the well should be at least 1 meter below the river bed, or 1.52 meter below the LWL. That means the bottom of the well means this bottom of the well, right? So this should be, you know, the river bed is there. So suppose the bed which you get, this one, it is quite, you know, that I mean river bed is this, suppose. So this is at least 1 meter below, and this actually with respect to LWL, that is actually 1.52 meters below, at least 1.52 meter below the LWL, that is the lowest water level. The height of the foot valve above the bottom of the well should not be less than 0.6 meter. That means foot valve means this non-return valve which you place here for pumping that one, right? So that foot valve, the non-return valve also, foot valve means non-return valve, that should be placed at least 0.6 meter above the well also, okay, above the bottom of the well. Now the well should be watertight, sufficient, watertight, absolutely watertight, and constructed of durable materials also, like RCC, reinforced cement concrete, with a minimum this wall thickness of 20 centimeter also. That means it is a quite heavy structure. So suppose I intake this wall thickness, that should not be less than 20 centimeter also. Okay. Now, and the bottom as I have shown here, that should be concrete. There should be a sort of solid foundation also, so that it remains stable also. It should not get toppled also, right? And another thing to be mentioned here, that is the weight of the entire structure must be, while checking that the structural stability of the intake well, because there would be, because as it is, you know, understand that it is on the river bank also, heavy water, this uplift pressure, that would be, I mean, working on that. So mounted from the bottom. So to safeguard against that possible, you know, buoyancy or uplifting of that I mean structure also. So the weight of the structure, total weight, must be higher than that. Remember this. So for structure also, that is why you have to, whatever structure you design also, that the concrete and all this one, RCC, whatever you, the total weight you must check, that whether it is, I mean, in excess of that, I mean, uplift pressure also. The minimum depth, as I have told, that 3 meter, but here it is written 2 meters or so, but it is better to follow 3 meters or so. That is the water inside that. That is given by Davies also. Then the other things, yes, more or less these are all. And another thing is that written, the guideline, the horizontal cross-sectional area of the suction well shall be 3 to 5 times the vertical cross-section of the intake conduit. So what intake conduit is there, is entering, so the horizontal cross-section also, that should be minimum 3 to 5 times the cross-section. That means suppose it is entering into that, right? through this, right, this one here. So this actually intake conduit, when it is connected with the intake, through the intake conduit to the river, then the cross section, the vertical cross section, that means this cross section actually 3 to 5 times this cross section should be the area or the cross sectional area of the tower also. So these are the more or less, I mean, the rest we will discuss later. Yeah, more or less it is. Okay. So minimum depth actually 3 meters, as I have already told. This is recommended by Davis. So here I will end up for this, current discussion on this intake. I hope that and pray that this video will not be, silent and slow, motion also. It will be proper, so that I could directly upload that for the registered, viewers also. Thank you so much. Okay, have a nice time.